that's a data distributed. But if you say that is interquartile range, that means IQR. Okay, interquartile range, that means it is the range of the middle half of the data set. What is the range of the middle half of the data set? Okay, what is the range? So this portion is called interquartile range. So if I say that let we have a range, as you know, I will tell you right now that interquartile range is of four types. That is Q1, this is Q2, this is what, Q3, and last one is Q4. If that we have the 100% data, that means if we have the entire data set, if we have a range of data set, that means for entire 100% data is distributed, right? So all the data are distributed properly. This is called the distribution, right? Okay. So if I divide this data into two, so we can say this is 25%, this is 25%, this is called 25%, and this is also 25%. So there are four quartiles in our data set, right? So here, so this is called Q1. That means 20% data is distributed properly. And here 100% of the data we have to make use of Q1. If we want to make tell you the 100% of the data distribution, if you want to know the Q2, then we have to work upon Q2. So if I want to know the result upon the 75% of the data distribution, then I have to just apply my analysis upon the entire data set. That means I will work up to Q4. That means the entire data set I will consider, right? So here quartile segments. These are quartile segments. These are four quartile segments. So quartile segment, that means this will segment the distribution into four types. That means we have segmented our entire data set. First one it is 25%, second one will be 50%. That means up to this we can have the analysis up to 50% data. Up to this we have 70% data. That means the analysis is done together. Okay. So this is called distributed data set. That is ordered from low to high into four equal parts. And remember, you have to segment the data into four equal halves. So that's why we have segmented it into 25 and 25%. So analysis is done upon 25% of the data. Q3, that means the analysis is done with 75% of the data, right? So you can see here result also. Am I not audible properly? Am I not audible?
No, it's
Okay. Okay. If I'm audible to some students, if I'm not audible, then you can also check from your side. There may be issue at your side. Okay. Is it clear? Now it is clear? Because I can check from my side the
yes.
network is okay. Yeah, yeah. Okay, thank you. What about Mahmood and Sylvester? Do you hear me? Okay, 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 okay. Okay, so shall I need to explain again these quantiles?
Yes,
If
come
it is
again, ma.
okay, see. Okay, see. Let me show that again. I am just saying about the data distribution. Okay, so if I will not be audible, please tell me that I'm not audible because as I'm sharing the screen, na, I can't read the comments. So here, these are the data distribution. Okay, so I'm just giving you the example of data distribution. So if I have a data set and I want to show the distribution, you know that there is a bell-shaped curve. That means the data is properly distributed. So here, if you tell the range of the data set, that means you can see that the data is spread over the whole data set. So whenever someone asks you what is the range of this one, you can say it is the spread of the whole data set is called the range of the data set, right? So if I'll say the quartiles, okay, quartiles, that means you can say that a proportion of the entire data set. We can have the quartiles. So if it is 100% data, that means the entire data set we have, you are interested in quartile, and that there will be 25% of the data present in that quartile, right? So IQ is what? This is the interquartile. IQR is interquartile range. That means we want to find that if the entire data we have divided into segments, if you have divided into quartiles, what can be the distribution? What can be the percentage of distribution in each quartile? Whether we have to do or whether we have to work upon the entire data set, or we are interested to work upon the quartiles, right? So we know that we have four quartiles in a data set. You can remember that there should be four quartiles in a data set, because entire data set we have to consider as one, a single 100% data. So we have to divide that into equal four quartiles. So each part will consist of 25% of the data. So first one will be Q1, second one will be Q2, Q3, and Q4, right? So four quartiles. So if there is something written that is 1Q, 1Q, that means it is Q1. If it is written 3Q, that means it is written as Q3, quartile 3. So if it is 1Q or Q1, that means we are working upon the 25% of the data distribution. If it is written as Q3, that means we have performed analysis of the 70% of the data. So if it is sometimes written Q2, that means we have just performed the analysis upon 50% of the data, not on the entire data set. Because whenever we do perform the analysis, then we have to predict the entire data set. We have to do the same process on the entire data set. So we have to just perform the analysis on the sample. So that's why we are dividing the data set into quartiles. So you remember that there are four quartiles: Q1, Q2, Q3, and Q4 of equal proportion. That was 25% of the data, right? Okay. Let's see. Here, why I explained you so many things, that it is written as 1Q and 3Q, right? So whenever the data, whenever this analysis, this linear regression analysis is performed on the 25% of the entire data set, that is empty cars, the impact of CYL on MPG, we receive this value. Okay, so whenever the analysis is performed on the 75% of the data, that the impact how this CYL impacts this MPG, we just received this kind of data. So these, you know, that is mean, median, max, you know. So I just to explain this, what is 1Q and what is 3Q. Okay, first quartile and this is third quartile. So these are what? These are the residuals, right? So residuals means what is the gap between the actual one, between the interpreted one. You can see this. I can show you. This is another. Okay. So here you can see this is what these black dots are, the actual data. Whenever we generated the model, whenever we generated the linear regression model, just these green lines are what? They are the interpreted values. So here you can see there is the gap. Here is the gap. Here is the gap also. So that means if there is the difference in the actual data and the interpreted data, so that will be called as residuals. You can see that few values are there. The actual data is same as the interpreted data. Here also, here also. Okay, only three values are there where we can have no difference between the actual and the interpreted data. But others, in case of others, you can see uh, large variance. This is large variance, this is large, but this is small, etc. That means there is some gap between the actual value and the interpreted value. So that is called residuals. Okay, am I clear? Am I audible properly?
Yes.
Yes. Okay, so we have to predict what we are predicting here. Can you say that from this formula we have written, what we are predicting? If you have understood me, you can also simply reply that what we are predicting. I'm predicting in this case. MPG with yield symbol predicting. LM, that means we are using the linear regression. We have used two variables, MPG and CYL. What we are predicting? Whether we are predicting MPG or whether we are predicting CYL. See your screen, see the studio you have executed, and tell me that if I am written that LM within bracket two variables, then which variable value is being predicted by me? Dependent. No, no, but or means what? I uh, get you that whether you are predicting the dependent or independent one. See, always remember one thing that we do not predict the independent one. Independent variable is like the input. If we want to have the output, we need the input. So that's why we are taking the independent variables. Okay, so independent variables act like a source by which we can get the output. That output is called a dependent variable, right? So whenever we are performing linear regression method, that means we are predicting that regression is what you have to predict the output. So whenever you are preparing performing the linear regression, as we are performing linear one, that means you remember that there is only one independent variable. We are not talking about this multiple regression, so we won't take multiple independent variables. So as we are concerned about this linear regressions, we will take only one independent variable, right? So here in this case that I told you that I want to predict, I have written LM within bracket MPG tilde CYL. Okay, so two variables clearly visible that two variables are considered from the dataset MPG. So what you are predicting? CYL is independent, right? Yes. CYL is one variable, right? The number of cylinders you can see. You can say also. So if we have met some changes in CYL, what will be the value of MPG? So we want to predict that. So that's why we are applying regression method. And as we have concerned about single independent variable, so we are just performing this linear regression. For that, we have taken a formula called LN. I think I'm clear to everyone. What is this summary method? Summary method. We have written this summary. We are preparing a linear regression model, right? So model prepared means you can take the variable as any name. Just I have given the name as model. You can give your name also. It will work. So it doesn't matter. That doesn't means vary. So here this is the method that we want to apply, and we are just putting all the activity that is done upon these variables in this system in this model. Okay, so whenever you will just display that, you will find the summary of that variable. Here I have taken the variable as model. It will give what is there in the execution. What is the execution is going on? What are the things that is being displayed here? So everything we can get in the output. So it will just start showing what is the method used, what are the data sets used, what are the variables used, and coming to this is the coefficient portion. To this, I think I'm clear. Okay, clear, right? Clear studio. Okay. We have received prediction. This is the thing, this is the value that I want to get. That if I change the value of CYL up to this unit, okay, this is the unit that I can change. So if I will just change, or if I'll modify the value, if I change the standard estimation to a cylinder to this value, what will be the actual MPG, what will be the amount of MPG that I can predict. Okay, so that is called your intercept, right? So many things are there. You can just you see your R Studio. I will just explain that cylinder. You see your R Studio. I think everyone just look at your R Studio. You can see the output. CYL value is written. Okay. So if I just change the value of CYL up to this unit, I can have the intercept. The intercept means it is the value of the MPG. So what is the value of MPG? I can predict that value is 37.8846. Right. So then what is the this standard error? These are the coefficients that I am just explaining. So what is this standard error? So standard error is also one of the coefficients. So what are the coefficients present in LM or linear regression? First of all, it was the estimation, that if I am just moving the CYL value up to this unit, what is the estimations or what is the prediction I am getting over MPG? So that was first prediction. Okay, second coefficient is standard error. So standard error means it is the coefficient. You can see, let me, okay, okay. Coefficients, right? Coefficients, another coefficient is standard error. Just look at your as Studio. Standard error is what? This is the estimation of the, you can say the standard deviation of the coefficients. That means in fact, you can say it tells us that how much uncertainty is there with our coefficient. Okay. Whether the model we have generated is well fitted to the data set. Okay, so whenever we have considered a data set, we have generated a model applying the linear regression. Depending upon the standard error, depending upon the deviation, we can also find out whether our model is beneficial, whether we have developed a right model or not. Okay, so this standard error is used to create the confidence level. Okay, so if you have much more confidence level, we can see that there is a less deviation or there is less error in the model we have generated, right? This is called standard error. Next, you can see from your screen, this is T value, right? This T value means it is nothing but the T statistics. This is the T test that we have already performed. So this is simply what? This is simply the coefficient. It, we can find out using the coefficient divided by the standard error. The standard error that I just explained right now. So if we divide the coefficient with the standard error, so it will give us the T value, right? So in general, we want our coefficients to have the larger T value, because if we have the larger T value, it says that our standard error is small in comparison to our coefficient. So if we have a larger T value received, we can also predict that we have a less number of errors in our model, right? So T value is also used to find the P value. You can also know that. Okay, from previous examples, we have seen that how can we find the P value. Last one is coefficient, that is PR within bracket greater than T. It is written on the significant quotes. So significant quotes, that is written as a 3 star, that means more significant. 2 star means less significant. 1 star means less significant. You can also do. So P value depends upon this is 0.05. This is the standard value you have. So if P value is less than 0.05, that means we are getting the more significant value. We have to reject the null hypothesis. So here coefficient P are greater than T. It means what? That P value is calculated using the T statistics, right? So P value in association with the T value, it helps us to understand that how significant our coefficient is to the model. That means in general, we want to know that the model that we have generated, whether it is significant or not. Okay, so we can get that using this coefficients of p and t value. You know that the significance level is 0.05. If it is less than 0.05, it is more significant, right? So you can see that the number of asterisks, you can see that three asterisks are there, two asterisks there, a single asterisks are there. That means the number of asterisks corresponds to the significance of the coefficient. I described that if there is more asterisk, that means more significant it can have. That means if our model we are generating something, we have received the p value, we have received the t value, that means our model is very significant. If our model is very significant, then we can say that our model is very significant or not. So if it is less significant or not. So we can also see that whether there if it get the prediction more, we should have less error, we should have less residuals. You can see that if there are means the residual error or the residuals are more, if there is a large gap between the actual value, the black dots and the blue dots that you can see the interpreted value. So if there is a much more gap, that means our residuals are more, that means we are not getting the proper model, because if you are getting the proper model, it will minimize that residual. Okay, so another thing you can see from your output, that is residual error. Okay, so residual error, you can see what is that. This residual error, that is RSE in short, it says that how well the model fits the data. So depending upon the residual error, if it is less, we can have the model fits the data. We can see that the model is well fitted to the data, right? So we can see that if we have a smallest residual error, so always try to reduce the smallest, try to find the smallest residual error. That means we have to perform the analysis in such a way that the RSE, that means residual error, that should be less. Because if the residual error will be less, there will be the much less gap between the actual value and the interpreted value. That means we can say that the model that we have generated is very close to the actual value. So we always need to develop such a model that is very close to our actual value. So for that we need less residual error. So if we have the less residual error, we can say that our model is very good. Okay. Another one next is says that you can see there is multiple r squared and adjusted r squared, right? This adjusted r squared, that means it is used for multiple regression, but we are not considered about the multiple regression, so we'll just see about multiple r squared. So this multiple r squared is what you can say that this is. Let me share the screen. Okay. Okay, so this is the significant codes I can see. This residual standard error that I just explained, that is RAC. So it is 3.206. That means it is a larger one, right? So it should be value should be something. So it's if it will be 0.2, we can say that there is the less residual standard error and our model is very close to the data, or we have just got the very good model. And here it is said multiple r squared and adjusted r squared. So this will be, we will just verify this one if we are using the multiple regression value. So as we are dealing with the linear regression, so we'll just see what is this multiple r squared. So this is what this is, you can say that this is a predictor, right? This is a predictor, or this is a one kind of predictor. This says that what is the variance that independent variable and dependent variable have. That also determines that how well our model fits the data, right? So you can see there is 0.72, that means 72% variance is there. So here you can say that we have 72% variance of MPG if we are applying treatment on the CYL. That means it has not covered 100%. It has 72% only. So we cannot say that our model is very good. So if we have the variance of 72%, impact of CYL on MPG. That means we cannot predict MPG if we will change this CYL. As here in this case, we are getting the F statistics as 79%, and p value is also less than 0.05. That means a large F statistics indicates that our null hypothesis should be true. That means if we will make change in the CYL value, it will impact this MPG. Okay, so F statistics is very large and p value is so small. Okay, so we have to reject the null hypothesis, and we can also conclude that there is a relationship. Okay, there is a relationship between our MPG and the CYL, right? Presentation. I have not presented anything. So how it will be visible? Right. I was just explaining, right? I told you that you see your screen, you see your R studio, the output is visible, and try to understand what it is. So I have not presented anything. So that's why it was invisible. Right? So you can see that F statistics is written as 79%. You can see from your screen also. P value is this much. That means it is less than 0.05, and F statistics is also 79%. So this is also larger, and P value is also less than 0.05. That means in both the cases we have to reject the null hypothesis. So if we are rejecting the null hypothesis, that means there is the relationship, because null hypothesis said there is no relationship. That means if you change the value of CYL, you cannot get any impact, or you cannot predict any impact on MPG. But as here in this study, that in our analysis we can reject the null hypothesis, so we can say that yes, there is the relationship between CYL and MPG. That means if we change the value of CYL, we can also impact, we can also experience some changes in this MPG. So what is here? So if you change this value, let me show you. If you change the value of CYL up to this unit, you can also get the value, can also predict the value of MPG to 37.88, right? So these are the significant codes. And you can see that our intercept, our output, our MPG or our prediction is 3 star. That means it is the most significant one. We are rejecting the null hypothesis, so that's why we are saying that yes, there is the impact, there is the relationship. Okay. Now it is clear to everyone the code, the output, because it should be very important to understand that what we are getting. What is the output? Here you can say the residual standard error is 3.206. It is very large also. So that's why our model is not so good. We have predicted value, of course we have predicted, but our model is not so good. Residual standard error should be minimum one. So as minimum it will be very good. So if we are getting 0 point something the residual standard error, so we can say that yes, there is no gap, there is no variance between the actual data on whenever we predicted those data in the model. There is no variance, there is no disturbance, right? So that depend, the model is very suitable to us, to other data set or not, that can be known from the residual standard error or the residuals, right? Okay. Any doubt up to this? You want to ask me anything? Show your, just see your screen, see the R Studio you have, and tell me what you want to ask, or if anything, if everything is clear or not. Okay. So am I clear to everyone? Okay. The time you told me that your presentation screen is invisible, I was not presenting anything. I was just explaining, right? I told you that you look at your R Studio and you can see the things, and I just explained. Okay. Anything want to ask me? Okay. Clear. Okay. Others getting an issue at any point? always in the coding portion, you try to understand each and every line, what is written, why it is written. Okay, it will be very good, so that it will you will be clear about the program, you will clear about the codes that you are running. And always try to run the code along with the instructor, so that it will be much more beneficial for you all. Okay, clear about regression, clear about linear regression, why we are using this LM function, why we are using the summary function, what are the output we received, how we can conclude that our model is fit or not, or whether the model that we have generated is suitable or not, how we can get, how we can interpret that. Are you all clear about this? Okay. What about Yusuf, Sylvester, Clear, Mahmood, Saibu, Anas left? Okay, okay. Output is clear to everyone, right? Yusuf, what about you? Are you there? Okay, Mahmoud, are you clear? Shaibu, are you clear? Okay, I hope everyone is clear.
Yes, ma, it is clear.
Okay, okay, thank you. Next. Okay, okay, everyone. Next, see. Next, I want to run another program, another means same on same algorithm, another data set I want to use, and I want to show you some few methods. Okay, few methods that upon which we can get some other outputs, right? So first of all, you want to do one thing. You just clear your console. If you have saved, you can also save this work. Or if you don't want to save, you can clear the console also. Okay, so I do not want to save my work, so I will clear. If you want to save, then you can go on file option, then you just click on save to save your work, right? So this will be saved. So if you don't need, you can clear also. Let I want to clear, this is control L. Okay, so I want to apply this linear regression method on another data set to use some other methods to get the output, right? So what we'll see, we have here also we have to call the library that is tidyverse, right? So let I want to call this. I have already installed. You all have already installed. So you have to call the library also. Only you have to call because we have installed. So let I want to call this library that is tidyverse, right? So here. Next, I want to work upon a data set. I want to perform the same operation, linear regression on a data set, but I want to make use of different methods, right? So just I want to use this data, within this data function, write the data set that is cars. I want to make use of cars. Then I can also write here cars. Okay. So whenever I use cars, you can see that it has two variables and 50 observations. You can see two variables and 50 observation. You can directly bring the data set in this way, or you can write also view. Okay, with V capital, within bracket you have to write the data set you want to view. So there are two methods. You can also uh, choose any one of them according to your convenience, right? So this is the data set that we just received, that 50 observations with two variables. So let I do not want to work upon the entire 50 observations. So I want to work upon 10 observations. So how can I write that I want to consider only 10 observations out of 50? So I have to write head, then within bracket, write the data set that is cars, comma, write the observation that you want to use. Okay, you can see now the output is reduced from 50 to only 10. Okay, you can see first 10 observations you need. Okay, so that's why we are writing head, and the data set that is needed, that is cars, and the observations you want to have, that is 10 observations, right? So are you getting the same output, everyone? First 10 observations. Let me show you again. Head within bracket cars comma 10. That means you want to get first 10 observations from the data set that is cars. So as you know that car has 50 observations, but we want to work upon this 10 observations. So we want to just extract 10 observations, 10 variables or 10 values or 10 rows from the entire data set, the first 10 rows. So that's why we have written head. Okay, show here. Next, I hope you all are doing with me the execution. Okay, next. Next, I have to write this cars data set, then percentile, greater than symbol, again percentile. Okay, what is the meaning of this statement here? So by this statement we assume that when creating a linear regression model, data has no extreme value. That means the extreme values that are not representative of the actual relation between the variable. That means we are taking only those values that are related with each other. We are not taking the values that are not related with each other. That means we want to just remove the outliers. So that's why we have written the data set in this way. Okay. So next we have to apply. Okay. We have to apply this LM. LM means linear regression. I want to find the predict the value of distance. Okay, distance, because it has two columns, that is distance and speed. This distance and tilde symbol, that is speed, right? Here the data is equal dot. Okay, see the method of writing. Then percentile, again greater than, again percentile. That means we are now using this data set cars. So that's why we have written is equal dot. That means it will just import this cars data set here, and we have written this because we are just here to remove the outliers, right? Let I am just writing summary of the data set. Okay, summary. Okay, whenever I just press the enter, I can have get the output that I explained in the previous example. Okay, I am getting different output, but the pattern is same. Okay, so try to understand what is here. So here you see I have distance is the dependent variable, speed is the independent variable, and data is a variable that consists of the data set that is cars here. So as we have just written cars percentile greater than percentile, that means here in this statement we want to find out that while creating a linear regression, why we are creating the linear regression, because we are writing here the LM function, and as we have taken two variables, one independent, one dependent, that means that we are performing this linear regression, right? So linear regression is performed on the cars data set. And why we have written the cars as in this way, because we have to just remove the outliers. Okay, there should be all the variables, or the variables should be related with each other. We do not have to consider any value that are not related with each other. So that's why we have written in this way. and we want to find the summary of the entire data set. So we have to write summary within bracket, do not write anything. So I told you that this in this example I will show you different methods of explaining the same linear regression. Okay, so this is the way by which also you can get the linear regression value. So are you all doing the same? Did you get the same output? Try to understand what I did here. I just used linear regression, but the method of using is different. Okay. Am I clear to everyone? Let me show you again. You do the same process and tell me whether you are just getting all the lines written here. This is the code person you first understand, then I will explain the output. The pattern is same, but the values are different. Okay, because we are concerned about the different data set and we are also considering the different variables. So that's why we'll get the values different, but the pattern is same. Right. So try to understand this coding. I explained it again. If you didn't get me, then tell me. I will explain again also. See the code and try to run this. Okay. Here you can see that LM is what? LM is a function that creates a linear regression model in R. So this function takes two things into consideration. First one is that it takes a formula, and second one is it takes a data set. This is what? This is a formula. Okay, what is the formula here? The distance and speed. That means if you will just make a change in speed, what will be its impact or how we can predict the value of distance. This is one parameter in the LM method. Another parameter is the data set. What is the data set here? We are using the data set as cars and we are storing the data set cars in the variable that is data, right? So it takes the independent and the dependent variable along with the data set. Okay, did you get? Am I clear to everyone? Okay, so these are the things that you received, that residuals I told you that this is the difference between the actual value and the interpreted value. So what is q1, what is q3, I explained. What is this mean, median, max also I explained. Okay, any doubt regarding this residuals? Means things are same, the pattern is same, but the values are only different. Okay, do I need to explain again? You can see the f statistics is 89%. Okay, the F statistics is 89%. P value is 1.49 something. So as you see that F statistics is greater. So should I accept the null hypothesis or should I reject the null hypothesis? You can see also residual standard error, that is 15.38. So it is greater, right? It is means larger value. And lastly, in previous example we have received the residual standard error as 3.2 something, right? So here in this case we are getting the residual standard error as 15.38. That means if there is the more residual standard error, that means we cannot say that our model that we generated, which is just predicting this the value of the dependent variable, that is the good one. Okay, so as we are getting the much more residual standard error, so we cannot say that the model that we are generating using the linear regression, that is the best one. Okay, that is not the best one, as we are not getting that our model fits into the data set, or our model fits doesn't fit into our expectation, right? So you can see also F statistics value is 89.57. Okay, so it is also a much more larger value. Previous example, we just received 79%. Here we are getting 89%. That means it is a larger value, and we have to reject the null hypothesis, right? So larger value means that our model that we have generated, it is not a suitable one, that it doesn't fit into our expectation. So we need to improve in our model. And as you can see that p value here, so we have to reject this null hypothesis. That means there is the impact of distance on the impact of speed on the distance. Okay, so if you increase the speed, there will be some changes in the distance. Okay, so here you can see that the result is, if the speed is increased by this one, the distance will be decreased. Okay, so that's why it is minus something, minus 17. So if you will increase the speed up to the unit 3.9, then our distance will be reduced by 17.5. So this is our estimation, this is our interpretation, right? So up to this, any doubt, or are you clear about this? Am I clear to everyone? Okay, Mahmood, thank you. Okay. So let's stop the session, and tomorrow we'll just study about cloud computing lab, right? Okay. So thank you so much for attending the session. Okay. Okay. Thank you so much. Okay. So let's quit the session. We'll meet tomorrow. Okay. Thank you so much. Thanks everyone for attending the session. So let's quit the session. Enjoy your day, and we'll just meet tomorrow.